Hello, I'm Philip. This is Stefan. We're going to give a two-part talk about declarative interactions. At a high level, this is a way to make interactions feel snappier on the web, and it's a way that we think can be integrated into existing content. So, at the heart of great user interface is responsiveness, this feeling that you're really touching something real on the screen. And when there's a large delay between when the user does something and when they see the response, this experience falls apart pretty quickly. Things start feeling sluggish or slow. Penelope at the keynotes was talking about how the web feels a little bit not right in some situations, and that's the kind of feeling we're talking about. But also responsiveness is important for just overall usability. If you push the screen and you don't see a response, you might push it again. Or you might do what's called rage clicking and keep mashing this thing until it finally works. This is all bad due to responsiveness. But even the most patient user might have thought they tapped the screen, but they didn't. And now they're waiting on a response that's never going to come. So responsiveness is super important. The way we measure responsiveness is using INP, or interactions next paint. This is the delay between when the user does an interaction and when they get the response. A lot of hard work has gone into this over the years through developer outreach and through new APIs like scheduling primitives, and through all sorts of other things, including this whole program. And it is extremely hard to sort of make a page that is fast and stays fast. For example, that is immune to adding a third-party library in the future that then makes things slow again. So it's just very hard to stay on top, especially with that long tail. And basically all content on the web is affected by this problem of responsiveness. And I wanted to give just an example of Google Search. The way Google Search works is that they very quickly type in a query, you get your response, they quickly put up the pixels, get the DOM out, put up the pixels, but then they schedule an asynchronous task that then synchronously hydrates that. They're basically attaching event listeners, doing things like that. And this is hundreds of milliseconds. If you tap during that time, you will be waiting around for hundreds of milliseconds before you see that animation even start playing or even start. So this is the problem that our presentation wants to solve, and we think it can be actually integrated into real pages like this. So let's talk about responsiveness from the perspective of an input event. This is sort of the life and death of an input event. An input event is born when the user pushes on the screen, and the event sort of goes through the hardware layers to, say, a generic compositor, which does a little bit of processing, and then we go on to the main thread. This is where we're going to calculate what update we want to show. For the Google search example, this might have been starting that animation of expanding something, or this might be like highlighting the color of a button. The main thread then passes this final state up to the compositor, which does a little bit more processing, passes it up to the hardware, and finally the user sees this response. So this is just a generic platform. How does the web differ from this? The web differs in one important way, and that is that the main thread of the web is much more congested than on other platforms. So this is because there's so many reasons. Some of them are things that, like threading on the web is significantly harder than other platforms. We have a DOM that's very attached by spec and implementation to the main thread. We have a lot more third-party script that runs on the web that might be out of your control. But for these reasons and many others, the web's main thread is much more congested. So on this slide, I have like a bunch of boxes down here. And these, other than the highlighted one, are all other things happening. So on the web, just like on other platforms, we get our input event coming through hardware, and then it goes to a compositor. Now the compositor, it wants to hand the event to the main thread, but the main thread is busy doing some work, some synchronous work. For the Google search example, that work might have been attaching those event listeners and hydrating the DOM. So it has to wait for that before the main thread can even start processing the input event. But then when main starts processing the input event, it might be slower than other platforms because there might be other work bundled into this update. Things like maybe there's below the fold layout content happening or other things like that. So this is even longer. So overall, this main thread is longer, more expensive than on other platforms. And then the web, just like other platforms, delivers the response back up to the user. So this congestion on the main thread, we can see this in our metrics for things like interactions next paint. And in general, main thread congestion is a main cause of response delay at all percentiles. and it is the main cause of response delay at the higher percentiles. And we would like to fix that. So our proposal for fixing this is to let the main thread tell the compositor enough information so the compositor can give the user response. Hey, I got your feedback, or I got your input. I'm working on it. That kind of feedback. Start an animation, change a color. We want to be able to do that very quickly before the main thread has even gotten the event in some cases. But we want to do this in a backwards compatible way, or a way that can be integrated into existing pages. So we still want that event to continue to go to the main thread. We just want to get that response out much faster. We think that this will solve sort of a long-standing problem of the web, but do it in a way that's implementable today. And to tell you how that's actually done, I'd like to hand it off to Stefan.
Thank you, Phil. Okay, so before I get into the details of the proposal, I would like to take a quick moment to look at sort of what we consider to be best practices for input event response on the web today. So the example on the right is an Amazon page, and the interaction you're seeing is that we've tapped on a little expander to look at top highlights, and it's a little chevron that flips 180 degrees, and then they show some content below it. So this is phony script, phony code, but I think it represents what's going on here. And you will notice that the input response is split into two phases. In the first phase, we start the animation on that little chevron indicator. We do that as soon as possible. The next rendering opportunity is to request animation frame. Because the property being animated is rotate, that is a property we can animate on the compositor. So this animation, once started, will animate smoothly on the compositor no matter what the main thread is doing, even if the main thread is blocked. However, crucially, it can only start by going through this main thread code. And then the second part of the input response is any other sort of more expensive work that you might need to do. In this case, it's maybe constructing the DOM for the details below. It might be fetching stuff off the internet. You don't know, but the recommended approach here is then to put that inside of a set timeout, which will run after that composite animation has been handed off to the compositor threads. That way, the animation will be running smoothly, even if the main thread gets blocked. Okay. What we propose to do is add a little bit of syntactic sugar, and that is animation trigger. This syntax means that if a click arrives on this element, then we should start its animation immediately. I want to mention that this is the animation trigger is not actually part of the spec yet, but it is already in development as part of a separate project by Rob Flack and David Awagbamila. Their implementation is focused on scroll events, specifically on triggering animations when an object enters or leaves a scrolling viewport. And what we propose to do is expand the syntax to also accept input events as triggers. Okay, everything else is very much the same. This is basically replaces the explicit animation starting code from the last example, and you'll notice that the on-click handler, we no longer do this set timeout delay. We just start running the heavy-duty work immediately as part of the handler. So as written, again, this is really just syntactic sugar. It would operate almost, it would be almost precisely the same behavior as the previous example. So why are we doing it? The reason we're doing it is because this syntax provides an opportunity for us to optimize this. And the optimization is to say that this animation trigger can be executed on the compositor thread before the input event is even sent to the main thread. So let's walk through an example. Or let's walk through the implementation. So the first step here is, actually, I would like to back up and say one thing, which is one of my favorite things about this project. We discovered in going through it that almost everything we intend to do here is simply extending existing code. There's very little functionality that we have to invent out of whole cloth. For the most part, this is simply adding a little bit more functionality to existing code paths. So already during style resolution is when we will parse that animation declaration, and we will set up the main thread's version of that animation. My little box down here is simply showing that this is something running on the main thread. So we're just going to modify that a little bit to annotate the animation trigger information onto the event, the animations that we're already creating. Okay, the next step, also occurring on the main thread, is happens during paint, which happens towards the end of a rendering update. It is already the case that during paint, we will generate some geometry information, which is used to drive hit testing, which is done on the compositor thread. Currently, the kind of things that we generate recs for are, for example, if a gesture event lands in a certain place, should we do a composited scroll? Can we do a pinch zoom? Can we do a double tap zoom? Can we do a pan, a sideways scroll? Things like that. If the mouse wheel is, if a mouse wheel event comes in, we look at where the pointer is and decide, should that do a scroll? So all we're going to do is add a little bit more geometry information to this, which is going to tell us, it's basically the little rectangles down here are all the animation triggers. So that gets included in this hit test information as well. All right. The end of a rendering update on the main thread is a process called commit, and that is simply copying data from the main thread onto the compositor thread. All of that animation data and all of the hit test information will be transferred to the compositor thread at that time. Okay, now let's take a look at what happens when an input event arrives on the compositor thread. We're going to do a hit test. That's already part of it. Now, if the hit test lands on an animation trigger area and the input event matches, we're simply going to take that pre-constructed animation and we're going to start playing it immediately. It will start running on the very next visual update to the user. Yep, and then after that, we will continue to propagate that input event down to the main thread just as we always have. And really the only change to input processing on the main thread is this. When the input event is handled on the main thread and the main thread detects that there's an animation trigger on the target element, then the main thread will copy what the compositor thread did and it will start that animation on the main thread. And that will mean that the compositor and the main thread now agree on the state of that animation, that it is running. And once that's done, it will then run any other pre-declared JavaScript event handlers just as usual. And this is it. This is basically, this is the whole thing, soup to nuts. Sounds good. Why don't we already have it? Well, I would like to talk about a few things that can go wrong or disrupt this. For example, what if the animation declared on an element is a combination of compositor-driven properties and non-compositor-driven properties? Like you have a rotate and you have a max width. If we start we can only really do compositor-driven animations with this. So if we were to start the rotate animation and the width one has to wait for main thread processing, they would probably look kind of weird. So we just are not going to do that. If we see that kind of animation, we will just fall back to main thread processing as it happens now. There are also some cases where the hit test on the compositor thread is inconclusive. Non-rectilinear geometry is a problem, clip path, border radius, things like that. In that case, we cannot determine for certain that an input event actually lands on the animation trigger. So again, we'll just fall back to main thread processing on that. And finally, tricky one, you may have an element which is occluding, painted on top of the animation trigger. And that element may have a registered event handler, and that registered event handler may have a stop propagation in it, meaning the input event should never reach the animation trigger. So the way we can handle that one is simply when we're in Paint and we're generating that hit test data, we can notice this and we will generate another hit test, like a sort of an exclusion region for the hit test data that says, if the event falls in this area, we can't do the optimization. We just have to fall back to main thread processing. So basically, the big story is in all cases, if we're not totally confident on the compositor thread, we just fall back to main thread processing. Okay. Now there is another class of problems which is a little bit trickier, and that is what I call the content race problem. And it is simply this. All of the data that we have on the compositor thread is a snapshot of a moment in time on the main thread. The canonical state of your application lives on the main thread, and it is dynamic. So it can happen that we generate this snapshot. It contains an animation trigger. An input event comes in. We start the animation. Then when the input event is sent to the main thread has completely torn up the DOM. The animation trigger no longer exists. It has moved around. Anything could happen. You know, we could have had a layout shift, and so the input event is actually targets some other element. Or, you know, you have arbitrary JavaScript running on the main thread. It could be that some other event handler just disables that animation completely. In this case, what will happen is that we will start that animation running on the compositor thread, and it will run for some certain amount of time. But eventually, the main thread will send a new rendering update to the compositor thread, which will completely wipe the slate clean and will stop that animation. So there is sort of it eventually, you know, there's eventual consistency here, but I think it is worth pointing out that this may be disorienting for users. It's something that they're not used to. You tap on something, you click on something, immediately something starts animating, looks good, and then it just stops. And you don't get the follow-on effect that you were expecting. So this is sort of a known risk with this project. To put it into context a little bit, this project fits into what I call the predictive model for compositor-driven effects, and it is simply this. All composited effects, including the ones we do now, are based on the idea of, if the main thread could tell me what to do, this is what the main thread would say. So in the case of a composited scroll, when the main thread is unresponsive, the compositor thread is simply saying, well, if the main thread could chime in right now, the main thread would be telling me to scroll. Or with the case of an ongoing composited animation, if the main thread is unresponsive, the compositor thread says, well, if the main thread were available, it would be telling me to continue this animation. It may not be true. You know, the animation may no longer exist on the main thread, but there is some delay in getting it to the compositor. So this is really of a piece with all of that, but I do think that the stakes are a little bit higher because, you know, if a composite scroll goes a little bit too far, if an animation runs a little bit too long, it's kind of no big deal. But like I said, if you tap on something and you see an animation and then you don't get, and then nothing else happens, that might mess with our mental model. I mean, Phil talked about rage clicking, but rage clicking is sort of based on, you know, the real world, which is users of the web have been conditioned to think that, like, if I click on a page and it just looks frozen and nothing's happening, probably that click was not received, and I'm just going to button mash until something happens. This is going to break that mental model for users a little bit, and I think we're going to have to keep an eye on how that plays out. I will say, at its root, the cause of this is the fact that when we do event targeting and we do a hit test, that hit test is based on the live state of the DOM. Michael Mockney, here's what I am saying. It has long been proposed that we should be performing the hit test for event targeting on the most recently displayed state of the DOM as opposed to the live DOM. I think it's a great idea in every respect. It's also a breaking change. And so it's not clear that we will ever be able to do this, but I just want to go on the record as saying I think it would be great, and it would also make this project less scary. Okay, I now want to talk about, like, you know, this is kind of a big idea, like handling discrete input events on the compositor and responding immediately in this way, we consider to be a bit of a paradigm shift. And we think it's very powerful, and we think that it deserves more exploration. For example, there is a current proposal that's in the pipeline to do something called pointer timeline. So, you know, animation timeline originally was always time-based. So your progress along an animation curve is defined by how much time has elapsed since you started it. Then we add a scroll timeline where we say, well, your progress along the animation curve is defined on the scroll position of a scroller. So this proposal, which just has nothing to do with us, but they're proposing that your progress along the animation curve is determined by pointer location. So mouse pointer location or finger location. That's this video that stopped playing is an example off the web of that effect. Now, that is a web page, looks good, right? Runs great. The only problem with that is it's smooth as long as you're not doing anything else on the main thread. But if you have a complex page, if you're doing anything else that might block the main thread, that's going to start stuttering and get janky. And so you can imagine if we could take pointer timeline and combine it with what we're doing and saying those pointer updates are now processed on the compositor thread and the animation updated on the compositor thread without hitting the main thread at all, that stays smooth even if you are, mining Bitcoin on the main thread. And going, beyond that, it's worth exploring if there are ways to enable sort of more sophisticated, more complex, pointer and gesture-driven interactions that can be handled completely on the compositor thread without touching the main thread at all. We think that this is like a green field for exploration, and we are excited to see what we can do with it. To sum up, animation trigger provides a way to reliably achieve the theoretically best possible input response time, regardless of main thread workload. I'm going to give myself a round of applause. I think it's worth taking a moment to let this sink in. I mean, Phil talked about this a little, but I'm gonna make a plea from the heart. Making input response reliably fast is kind of a holy grail on the web. And there is a lot of great responsive pages out there that do a really good job of it. But, at the long tail, at the high percentiles, at the margins, 1 time out of 10, you just, you lose, you get unlucky. And there's just some big task on the main thread that slows it down. And in my experience, users are really sensitive to this. Once a user sees 1 or 2 slow interactions on a page, they really make a quick snap judgment that this page kind of is trash. And so if you think about it, if this plays out as we think, that entire phenomenon is a thing of the past when you're using this effect. Every single input event response, at least that little animation part of it at the beginning, which we think is critical, that happens immediately. Best case input response time all of the time. So again, this feels like a big important development. And once again, some of the things we love about this project are it actually fits really well into our existing model. We don't have to do a lot of work. The sort of philosophy and the mode and the heuristics around existing compositor-driven effects fit really well with what we're doing. And we think that it, sort of opens the aperture to consider other ways to do complex gesture-driven events on the compositor thread. That's it. Thank you.
Time for a tiny bit of questions.
Okay. Questions? Dominic?
Hold on.
Phil?
So you mentioned when we're not confident on the compositor thread, we have to fall back to the normal main thread path. So like if we're animating properties that imply a non-compositor animation, we can't do this. Are those properties consistent across implementations, or is there like an interoperability concern? And like, how does that look? Is that a concern with actually implementing this and testing it and so on?
It is not interoperable. It is not interoperable. Just to give just one example, there's a project currently in development to animate clip path on the compositor thread. I think Firefox has that. Do they have it?
I'm not sure about it. I'm not sure.
So no, there's no canonical list of compositor-driven properties.
Okay.
But what I would say is, this is an optimization. The sort of dumb implementation of this feature simply runs on the main thread, and it's basically a polyfill or a syntactic sugar for what we would already do, and that will be the fallback path based on a property you cannot drive in the compositor or any other situation that you can't handle. So it'll simply be, I don't think there's any interop concerns in terms of, like, it's not web detectable. It's just, visual
Yeah.
smoothness. Yeah.
That makes sense. One last question. The main thread clobbering state, like where, okay, like where you start something and you run an animation and then you have to back out, like right when the main thread like gets synchronized back with the compositor thread. Do we know, like that is weird and that has its own downsides. Do we know how often we might run into that? Like if we tried measuring, like if we were to liberally apply this as much as possible, like how many cases, how often do we actually run into the case where we would start, but then we'd have to stop if this were applied?
It's a great question. Oh, no. Oh, okay. No, we do not know the answer, but I think something to keep in mind about how bad this problem is today, when this occurs, the user just did some bad input. You know, they clicked on something that they totally didn't mean to. So because we don't think it's likely to be super catastrophic, but we do not have information about it today. The question is it possible to get it? It's a great question. So one of the things, this project is going to have to paint the regions for hit testing. It's going to have to paint additional ones. So it's sort of, if we do this project, we'll be able to do a follow-up project to deliver hit tests to what the user was actually looking at. So yeah, actually, I think we might be able to measure it with this. Yeah, after the fact. Yeah.
Who's the one over here?
Maybe I missed this at the beginning. What's that? Oh, I'm Rob from Microsoft. If I missed this, I'm sorry. If suppose the animation was a little slower and the user tapped twice, would the animation play twice? Would it kind of cancel? Like, what would happen?
So this is this gets into a little bit of the nitty-gritty of how we're going to integrate into the existing animation trigger property. They haven't. So in my example, it says click once, so it would only run once. They have, you can also do repeat or invert or other things. So we were gonna, you know, if you click twice and it was processed twice in the compositor, that it would probably flip. But it will be, you know, customizable.
Okay, thanks.
Over here.
Hi, I'm Jelle from YouTube on smart TVs, and I agree this is important and big for us because sometimes our main thread only has a 900 megahertz core to run on. I got a question, like for keyboard inputs, can you filter this by key press key code, like only in if certain key codes hit this event? Secondary question, what happens with ancestor elements if they also have animation trigger defined? Do they all trigger or only the one where the hit test hits, where the event is delivered?
Okay, so I think in answer to key code question, that's not in.
Actually, I think yes, based on Tab's recommendation. So Tab recommended that we make this API general so that we can do that sort of thing on a per trigger type. I think that's the right choice. So I think that we could do key codes. But you had a second question.
Oh yeah, so about stacked animation triggers. So the input event will determine that. I think, you know, on the compositor thread, we would only start one animation, which would be the top one, the foremost one that you land on, because we can't do bubbling on the compositor thread. We just do a simple hit test. The main thread can do anything. So if you have a stacked animation trigger on the main thread, you may wind up with two animations, but only one will be the fast path.
There's person or two over here. There we go.
Hi, this is Sunny from Google. So this example that you show here, so it works to expand the details pane, but it doesn't fill it in, right? Like that one is still happening on the main thread, right?
That's right.
So,
that's why populate details is doing the rest of it.
Yeah. So isn't that like still a concern? Like, you know, the user taps on it, it does expand, but it doesn't like really fill it in.
It is. But I would say it's up to the website author to make sure that they're like, if you do a chevron flip that goes 50 milliseconds and your content's not ready for 400 milliseconds, I'm going to call that your problem. So maybe you need a spinner, right? You need to do something that's like appropriate.
All right.
Yeah.
Thanks.
You got it.
Hi, Adam from Google. You mentioned earlier that if there's a stop propagation event on a child element, that would like cancel the whole thing, and you'd have to go back to the main thread. But how do you know that there's a stop propagation if without actually going to the main thread?
We don't, but what we do is anytime there is an occluding element that has an event handler registered for the matching event type, we conservatively assume the worst and say, well, again, we're not disabling the entire optimization, but what we're doing is emitting an exclusion region in the hit test information that says we can't do it for that. So we just assume the worst.
Okay, thanks.
All right, I had a question over here, Steve.
Hi, Steve Kobus from Google. Have we given up on making the main thread fast?
No. No, definitely not. The main thread is super important. Like the main thread is going to block you from actually like doing the real work to get some like make a request and things like that. It's still super important. This is just a usability improvement.
I'm a little bit. I mean, this is really cool, but it feels like it's adding another layer. Like front-end web development is really complicated because we have so many different, we have a client, we have a server, we have potentially back-end systems, and then so it's like an end tier thing, and you're adding another tier now because you have to think about like what's running on the compositor thread and what's running on the main thread. Can we do this in a way that developers are not kind of exposed to that complexity?
So one thing that I liked about this is we sort of started out with Google search example of expanding an expando that spins a chevron, and this thing just like fits right in where you just declare that this thing's going to be triggered by an event, and everything else just works. That's the goal here.
Yeah, I don't think this is any more complex than, I don't think it's any more complex than what developers are already doing. And maybe it's slightly less because it is declarative. They don't have to do the request animation frame or the set timeout. I don't know. I'm not saying it's like fixing the problem, but I don't think it's any worse.
Yeah, it's a step more than doing it badly, but it's better than doing it good.
Yeah.
All right, Michael from Google. Oh boy. So yeah, and we're teaching these patterns of like handle events and provide an initial feedback immediately, then sort of yield, pause, and get to the real crux of the work. And so folks are already learning these patterns. And if you were to go back a few slides to the original code, like the RAF example, yeah. So you have to very carefully orchestrate that right now. You have to apply the style with the animation, get out of the way, allow a paint to happen, allow commit to happen, and then schedule the real work later. So beyond doing this on the compositor earlier, like beyond that benefit, there's another benefit where the real event handler gets to populate details, and those are prioritized another way. So you sort of pay the price twice here. You have to get scheduled twice with lower priority. This is easier to express and will be faster ultimately. But that leads to my question, which is, if you do provide a graceful fallback where you just go to the main thread, if you don't express this pattern, this explicit one, you're actually kind of doing the slow path. Because now you don't, like, you'll have to run the event listener in that same animation. So I just wanted to ask if, could you have passive mode event listeners where we'll actually delay the main thread event? Run the animation on the main thread synchronized, but the event be delayed. I might be getting into the weeds. But.
That is a really good question. I don't know. I mean, it sounds reasonable. Certainly like we could have used a set time outside of RAF again to achieve it here, but it is weird to ask developers to do that when you don't have that two-step process. So it's a good point. I don't have an answer. Do you have an answer? No. But yeah.
All right, we're out of time. So thank you very much.